Hello and welcome to COP 4708, Applied Database 1. I'm your host, Dr. Ron Evelyn. This is Module 7, Lecture 1, and we're starting SQL, Introduction to SQL. You're going to love it. This is the real thing, people. We're getting into it. First, what is SQL? Well, SQL stands for Structured Query Language, and it is specifically that. It's a language with which to perform queries. It's very well done. IBM in the 70s came up with this, and then it became an actual standard in 92. Back before 70 and 90, back up until 92, it was well on the path of becoming a standard. Remember, it's a NIST standard. It actually has versions, and it does change. It's not 100% static. Now, the old SQL commands, the basic SQL commands, aren't going to undergo any radical changes. But as technology evolves, we do add new things, just like we do with everything. So don't think of it as a programming language. It's not a programming language. There are programming languages that use SQL. In fact, all the programming languages that are used in modern times actually use querying, and there's actually versions of SQL, and you can enter SQL commands to database. It's actually a declarative language. You say, database, I want this, and the database knows what to do to respond for this. It allows you to query. It does other things. But it has commands. And that's the concept of a declarative. Unlike a procedural language where you just algorithmic it go bop, 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 step by step. It's pretty much in everything, and you do need to do NoSQL. You're going to hear the term, are you a SQL programmer? And avoid the temptation to say, well, SQL's not truly a programming language. Just go with the flow. Say, yeah, I'm a SQL programmer. I can program in SQL. Knowing fully well that that's actually kind of not really the case because it's not really programming. So, SQL is broken down into two parts, really two major parts, DML and DDL, the data manipulation language and the data definition language. The manipulation language allows you to actually manipulate data. It actually lets you take the stuff that's in those tables and do stuff with it. And here are the four biggies: select, insert, update, and delete. Okay, basically putting stuff into tables, okay, getting stuff from tables, changing the things that are in the tables, and getting rid of the stuff that's in the tables. Those are the four things. And the commands are select, insert, and delete, and update. So we actually have in programming language, we actually call it what's called CRUD. Create, read, update, delete. Okay, well, create is just a term for insert. Okay, but CRUD would sound really weird if it was IRUD. So, we go with what we've got. Now, it also has a data definition language. This isn't really how you build the structure of a database. We can say create user, but we'll come back to that one. Create table's a biggie because when you use SQL, you create tables. And I bet you can logically kind of think about how this works. You'd say, write the command create table. I need to give the table a name, table name. Okay, now I need to tell it what rows are in the tables. Okay, parentheses. Let's start entering the names of rows. We need to enter a row name, and maybe we need to tell it what kind of data type it is, and then maybe some other information about that row. Well, guess what? That's exactly how it works. It's perfectly logical. You'll see it as we go along. Okay. In the data definition language, of course, you have the ability to create. You also need the ability to make changes. So guess what? You've got the alter command, which lets you to alter things. And you will be altering tables. Now, when I say alter a table, that might be adding something to a table. It might be deleting a column from a table. That's altering a table. It may be adding a foreign key to the table. That can be done with alter table. Okay, and of course you can get rid of stuff. And we use the command for that, drop. You drop the table. Okay. Pretty straightforward again. It's not that hard. So just be careful with using this command. All right. Tables have security. So in the DDL, you also have the ability to grant privileges, like I'm going to allow this user to see the results of this query. Okay. And of course, if you can grant stuff, you also have to have the ability to revoke stuff. Okay, these are just commands. You're going to actually use these commands to do stuff, so we're going to kind of go there. How we're going to go there? We're going to go there with an example. So this is the View Ridge Gallery example. It's just one of the examples from one of the books here. That's the Cronky book, which is a fine book, and this is one of the examples there. So what we're going to do is we're going to build a database to help these guys out. Okay, it's a small art gallery. It sells art. It has one owner, 3 salespeople, 2 workers. It buys art and then it sells it. Okay, that's what we need to do. So you need to write an application, which means you need to write a database underneath it that tracks the customers and their interests and the purchases that the gallery makes and the purchases that the customers make. And it should be able to list the artists in the works, all of them, the ones that have appeared and the ones that are for sale. And you kind of want to know how quickly the pieces of work sell and how much money you made off of them. So in doing so, we've come up with this wonderful database design. Notice that the relationships all have descriptions on the relationships. We have customers that have transactions, and the transactions are to works of specific artists. And then we also got this customer artist int. That is a table with a dual foreign key primary key. That looks like a pretty decent design to me. So how do we do this? We've designed the tables. We now need to make the tables. Now, SQL has multiple ways of actually doing the same thing. It's a declarative table. The first thing that you're going to actually do is create the database. And you can create database view ridge gallery because the tables are all going to exist inside of that database. You can also create the database by, when you're using the tools that you're using, clicking on the tool and say create database. That's another way to do it. And then you put the tables in that specific database. Let's look a little bit more detail. If we take this artist and work relationship that we have here, how do we create these tables? Well, first thing is the good old create table. Now, one of the things I do in the create table, and I didn't do it in this one, is anything that is a keyword, like the create here and the table. When I write my SQL, I like to put those in all caps. I don't put the declarations of the data type in all caps, but like the not null, I do put in all caps. I didn't do it in this example here, but I will normally do that. And remember I said, is it logical? Well, create table, then the name of the table. Now we're going to make a list of all of the columns in the table with their names first, their data type next, and then any descriptive characteristics that have to go with that, other than the data type, which is also a descriptive characteristic. So what do we mean by descriptive characteristics? Not null would be one, unique would be another. You can also actually declare this is a primary key up here instead of down here. It's doable. It's another way because it's a descriptive characteristic that's actually in the creation of the table. I can do the same thing, by the way, with foreign keys, but I'm not going to do it this way in these examples. You're going to actually do it with the foreign keys by altering the table and adding it, but it's doable right there in the creation of the table itself. The tool you're using in my class, SQL LiveSQL. And here's the basis of LiveSQL. You're going to create a LiveSQL account. It's an Oracle database underneath it. It's completely online. It lets you do everything online. So create an account. And once you create an account, you're going to have this nice little tool on the left-hand side. You'll either be able to click on SQL Worksheet, or in the main page of MySQL, you'll see a thing that says Start Programming. And what that'll do is it'll take you to a SQL worksheet. And what this will do is it will allow you to just issue SQL commands. You type in the SQL command and you hit run. So if you make a create table and hit run, it's going to say table created. That table will now exist in your database. Woohoo! That's it. Voila, it's easy. Okay, that is actually one of the beauties of it. When working with the other programming languages, other databases, one of the databases would be like SQL Server, and usually that you're using SSMS, SQL Server Management Studio, when you're doing that. It also has a worksheet. And MySQL, which uses PHPMyAdmin as one of the admins, it also has a SQL worksheet. Okay, so some information here. Well, the create table artist, table is a table, but there it is. Okay, but notice that the table has columns, and the columns have names. By the way, don't call the column name a column name. I tend to avoid that. In this case, we do, but that's tend to get kind of confusing because name can also be a keyword in SQL. All right, data types. Here they are. The data type that I use most commonly, nvarchar2, number, date, and some of them have date times. This one has timestamp. Okay, but those are the ones that I'm going to use a lot. Binaries are used every now and then. I want to throw a blob in there, and a blob is just that. It's a large binary object. Okay, because you can store large binary objects. When you store numbers, which is one that you will use frequently, you can specify the precision of the numbers. Nice. Constraints. Of course, you can put constraints into your database. You can say what the constraints are when you're making the table. You can say what the constraints are after you've made the table by using the alter table to do that. So when we did this, we'll create the table. We've created the table. By the way, once you create the table artist, if you try to create it again, it's going to say table already exists. It's not going to want to create it again. Oh well, guess what? It does already exist. But now we can create a second table. Create table work. Remember, we have that work table. And notice in the work table, we had a primary key and a foreign key. And notice when we put the foreign key in here, references artist. So what this is saying is that this foreign key, artist ID, which is this field, this column right here, references artist. It references this table. Now I was like, wait, but how does it know what field it's referencing? Well, it's a foreign key. It always references the primary key of the table. Pure SQL actually will put in parentheses here, artist, parentheses, artist ID, to say what field it is that it's doing in it. And that would also, by the way, work. This allows you to shortcut because it makes the assumption that, well, we obviously know the foreign key is referencing the primary key of the other table. What else would it possibly do? That's it. And then you can throw in your cardinalities. Okay. You can also throw in default values and data constraints. Okay. You can actually set up constraints. Now, normally what you're going to do is you're going to come in after you've created the table, or you can do it while you're creating the table also. But we're going to show the alter statements, and we can add in constraints. Now, here is a little bit of one of those things that you will probably not do it this way. The first one, alter table, artist add, and you're going to add the constraint nationality check, and you're going to check to see if the nationality is in this specific list. In other words, it will only allow you to put items in this specific list into there. How does it normally done? Well, we would normally set up a nationality table. And instead of checking to see if it's, this is what we would call hard coding the constraint, normally we would check to see if the nationality is in a column in that table. But to do that, you would have to put a select statement into this alter for the constraint. We haven't learned select yet. We'll do it this way for now. Another one here, and you can see in this case, because the birth date and deceased date are both dates, and dates can actually have less than, greater than, and equals, we can set up a constraint for the values to say, oh, the birth date must be before the deceased date. Those are good types of constraints that you can throw in there. You can also do different types of formats. Okay, I don't know how many of you are familiar with regular expressions, but those are something that you can do. And so you can say, hey, does it follow this specific format, which is the like, which is a form of regular expression. And you can drop the constraints. Alter table, artist, drop constraint, valid def year. Because the constraint, by the way, has a name. Nice. So once you have created the artist table in here, you can look at the artist table. You can say show, you can show all. I want you to get in there and just play with the schemas, the worksheet. See that menu over there on the left where you've got the ability to save scripts, go through tutorials. I don't use Quick SQL, but feel free to play with it. And you know, it's a nice little tool, and it's online, and you're connected to a real Oracle database, and it's free. Free is good. Okay, and you can also look at the constraints, the indexes, the triggers, all those types of things in good old LiveSQL. Now, what if we wanted to do all this at once? No problem. Got it. There it is. Okay, notice you've got the create table, artist, name. Okay, you put all those together. You set the primary key. Notice that we put things into quotes here. In the case of when you're adding the constraints, it does make sense to put the names of things in quotes, and then and also to spell Mexican correct, because I don't know where Mexico is. I've never seen that country. I'm kind of joking here, but if you're paying attention to the slide, you'll catch this. Hey, but you can see, not that difficult to do. Okay, you can drop columns. You can add columns. Oh, you know what? We left out email. Alter table, artist, add email. Make it a varchar 2 and allow it to be null. That is it. I know, and also it is as the artist table, not the art sit table. Man, I am a terrible typist. Anyway, artist, I think you get it. But look at that command, alter table. Okay, I'll alter the table. What table are we going to alter? Oh, artist. What am I going to do? I'm going to add. What am I going to do? I'm going to add a column. Well, you add a column, you got to tell me what it is. Okay, it's a varchar 2. Okay, do I have to put, by the way, do I have to put that null in there? No, I do not, because by default, it's nullable. If I left it out, now if you want it to be not null, you got to put that not null in there. Alter table, artist, drop column, email. Be careful when using that. Now, to drop tables, by the way, if a table's got a constraint that's based on another table, you can't drop the table. If a table is dependent upon this table, you can't drop the table. Okay? But remember, when you drop the table, you drop the table and all the data that's in the table. Be careful. Okay, if you're going to use this. Okay, this is really for the design phase. You will be making modifications to tables. A lot of times what I'll do is I'll script out the entire database into a single SQL, all the tables, all the constraints, everything. As I'm doing the design, I'll look at how that design works, and then I'll go, you know what? I need to make changes. I will drop the entire database, make the changes to the SQL script, and then rerun it with my changes until I'm happy with it, because once I start entering data, I'm not going to be able to do that anymore. Adding data. Haha, you need to know how to do this. Here it is. Insert into artist. And there it is. There's artist ID, name, nationality, birth date, deceased date. Now, just for those people who have familiarity with databases, I would probably make artist ID an identity field. And in that case, I would not include artist ID in the value here because the table would do it automatically for me. Also, I know all you people who are familiar with the insert command, if you know the order of the columns in the table, you don't need to put that first artist ID, name, nationality, birth date, deceased date. You can just put, boom, the values there. Hey, that makes it a little bit easier. It's a little bit shorter, but again, there's more than one way to insert data into a table with the insert command. And when you're deleting, or well, in this case, we're updating, we're not deleting, but when you're updating, it's the update command. Update. What do we want to update? Oh, the table artist. Okay, what do you want to do? Well, I'm going to set nationality equal to Canadian. If you leave out that where clause, guess what? Everybody in your table is now Canadian. You have no artists from any other countries. Yep, because you just told it to set the nationality of all the artists Canadian. Where artist ID equals 9. And remember, okay, that where is kind of important. It's even more important when you're deleting. Delete from artist. I see people do this all the time. Where did all my data go? Well, you wrote delete from artist without a where clause, so guess what it did? It deleted everything. Delete from artist where the ID, that will only delete the one row where the artist ID is equal to 5. Okay, it's a command. It does exactly what you say it is. And I think by now you're actually going to look at it saying, well, it's not really a programming language. I'm just shouting commands at the database. Yep, that's exactly what you're doing. You're shouting commands at the database, and those commands, it is a specific language. Programming languages, people say, oh my God, programming languages are so hard to learn because you got to learn, and they're so finicky. They won't, you try to compile them, and then they say you had an error. No, you had an error. You told it to do something it doesn't know how to do. They speak a very specific language because you don't want them making decisions about what to do. Humans do that. You say to a human, go get me a cup of coffee. And humans kind of can translate and say, oh, he wants a cup of coffee. I don't know whether he wants Java. I don't know whether he wants it hot. I don't know if he wants it cold. But I'm going to assume this is going to be a hot cup of hot coffee with 1 sugar and 1 cream because that's pretty much average, and you'll get that. A computer would have no clue. You would have to specify all the specific parameters if it's not going to assume. However, you can program it to make these assumptions. Say, in the case where cream is not specified, 1. In the case where sugar is not specified, 1. In the case where the coffee that is being requested is not specified, okay, plain old breakfast blend. In the case where the volume is not specified, 12 ounces. In the case where it's not specified cold or hot, hot. Hey, guess what? That is programming. This is a declarative language, declarative programming language. You're going to like it. It's actually, now you're starting the real thing. Have fun. On out.